So I have a couple examples of the chain rule with trig functions and noticing the difference between when you have to do the chain rule once and when you have to do the chain rule twice. So with our first one here, we have the sine of 2x. This is just the same as the cosine of 2x. We think about this u value, and our u is 2x. So the derivative of that is not equal to 1, so I know it's a chain rule. But if you rewrite this f of x equals the sine of u, then we take the derivative, and the derivative of that is cosine of u times u prime, which means I can just substitute back in here cosine 2x times 2, and then rewrite this as 2 cosine 2x. So that was just a single chain rule. Probably you don't need to use substitution to complete, but it always helps to note that process, especially when we start to undo that process. So for the second one, the first thing you always recognize is when there is a trig function to a power, you want to rewrite so it looks like a power rule problem. And then this time our u is the inside. So really we're taking the derivative of this u, and that's just the power rule. This is where we talk about the outer and the inner, derivative of the outside times the derivative of the inside. And you get stuck on these, it helps to write them with the u. So this is 2 times u to the first times u prime. Substitute back in, sine 2x. And then u prime we already did over here. It's the derivative of sine. So it's actually the same what we just did down here. So it's 2 cosine 2x. So you'd write your final answer. 2 times 2 is 4. Sine 2x cosine 2x. If you want, you could apply a double angle rule, but there's no need to do that unless we have to. So again, the difference between single rule and double rule, chain rule. Okay, let's keep going here. Let's do the same thing with a function. So anytime whatever's on the inside is not the derivative, does not equal 1, you need to do a chain rule. So try to rewrite it as a power if you can. So it's the outer times the inner. The derivative of the outside, 1/2 x squared plus 4x to the negative 1/2 times the derivative of the inside, which is 2x plus 4. Rewrite it as a fraction. You're going to have to solve this way, you might as well. So the x squared plus 4x to the 1/2 now is positive, and the 2x plus 4 here is in the numerator. When we get to finding critical numbers, we want to know where this is 0 or undefined. We can tell 2x plus 4 equals 0. When x equals negative 2, and then for the denominator we can set that equal to 0. X squared plus 4x to the 1/2 equals 0. Square both sides. X times x plus 4, and you get x equals 0 and negative 4. So those would all be critical numbers. Negative 2, 0, and negative 4. And you can always check to make sure your critical numbers are the same, or are defined on the original function. And they are, so it works out. Let's do one more chain rule problem with fractional exponent f of x equals, let's do a trig and fraction all together, and a product rule. 2 sine x cosine of x to the 2/3. Okay, so first of all, this is a product rule. So I'm going to take the derivative of the first times the second plus the derivative of the second times the first. I'm calling this my u, and this is my v. So I have the derivative of the first, which is 2 cosine x, times the second as is, cosine of x to the 3/2, or the 2/3, plus the derivative of the second, which is 2/3 cosine x, 2/3 minus 3/3 is negative 1/3, times the derivative of the inside, which is negative sine x. That's the derivative of v, but I still got to multiply that by 2 sine x. So cleaning it up, cosine of x to the first times cosine of x to the 2/3. This is 3/3 plus 2/3. This is 2 cosine x to the 5/3 plus negative 1 times 2 is negative 2 times 2/3 is negative 4/3. Cosine is to the negative 1/3, so put it down here. And then the sine x goes up here. Probably if you're going to solve, you need to find a common denominator. Since this guy over here is over 1, our common denominator is going to be 3 cosine of x to the 1/3. So I have to multiply, because this is missing everything. The 1 is missing everything. So I multiply, and I get 6 cosine x to the 1/3 plus 5/3 is 6/3, which is 2, minus 4 sine x. Much easier to solve when you have it written as a fraction. Get used to it. It's just how the form it's going to be. And that's some chain rule.